All right, before before I solve another example, I actually want to look back at this one that we just did, and I kind of want to talk about it a little bit more. But this page is a little cluttered, so what I'm going to do is I'm just going to extract some of this, probably just this, take it over to the next page, and then we can do some work on it. Let's drop that here, and then I can go and erase this, and some of this other stuff that we don't need right now. Okay. All right, so we're really just gonna look at this resistor by itself, because this is just a good time to kind of explain a little bit more about Ohm's law, and about how circuits work and what Ohm's law is really saying. I used it in the previous example. I'm going to use it in the next example, and you students will be using this all throughout the course, every time you solve a circuit, most likely at some point. And Ohm's law, what it tells us is it tells us the relationship between the voltage across the resistor and the current through the resistor. And maybe that's clear already, maybe it's not clear, but what I'm almost certain I haven't made clear yet is, what does this arrow tell us? How do we know which way to draw it, etc.? And so instead of drawing my resistor vertically the way that I have been in circuits, I actually am just going to go ahead and nuke this, and I'm going to draw it just like this. This is some resistance R, and on one side of our resistor, of course, we're going to have some voltage VA, and on the other side of our resistor, we're going to have some voltage VB. Okay, so I guess solve using Ohm's law is probably a bad title for this slide. I'll just leave it as Ohm's law, because I'm really just going to explain a little bit extra about Ohm's law that I feel like I haven't done a good job of explaining up to this point. So right now, we're looking at a resistor, and we have voltages on either side of this resistor, node voltages, VA and VB. We have a resistance R, and then there is going to be some current flowing through this resistor I, but how do I know whether it's this way or this way? It could be either way, right? Well, the way that we know which direction the current is going to flow depends solely on VA and VB. And what it depends on is VA or VB the larger of the two voltages, okay? So, I had to do not disturb my phone. It's just blowing up right now. But what it depends on is whether or not VA or VB is the larger of the two. So actually what I think would be a good idea to do is for me to shrink this a little bit, and then we can get two of these on the screen. Let's get another one. Okay, I don't know why that didn't paste in the right size, but okay. So let's say in the top case that VA is larger than VB, okay? If this is the bigger of the two voltages, then the current is going to flow from VA to VB. Okay, that's going to be the direction of current flow. So my I would be from left to right. Okay, in the second case, let's say VB is greater than VA. Right? If that's the case, the current's going to flow from VB to VA. All right? And so my I would be drawn as such. Okay, and so this is an important concept, because sometimes let's just say that I am looking at a circuit. This has like a 9-volt battery, and then over here there's some resistance, and I label this side ground. So you know this is 0 volts. We know this is 9 volts. So right off the bat, even without me labeling it for you, you would know, oh, my current's definitely flowing downward from the 9 volts to the 0 volts, because I know that current flows from the higher voltage to the lower voltage. Okay? And so what would happen then in a case where, what would happen in a case where I flip this battery? What if I were to draw it like this? Now what would happen? Okay, this is an interesting concept here. I haven't seen this yet. So I'm going to erase my node voltages and I need to reassess. Okay, so what do I know first? What I always know is that ground is the 0 volt potential. So this net on the bottom here is going to be 0 volts. I also know that a battery tells me that the plus side of my battery is 9 volts higher than the minus side of my battery. Okay, so if it's 9 volts higher and the plus side is at 0, then my negative side would have to be at negative 9 volts, right? That is correct. We can have negative voltages. So this side would be at negative 9 volts, all right? And so in this case, what direction would my current be flowing? Well, it flows from the higher voltage to the lower voltage, and 0 is definitely higher than negative 9. So in this case, my current would actually be flowing this way, okay? And so one final concept here, I think this video has probably gotten a little bit long, but the last thing is that that current is going to flow all the way through the circuit in the same direction in a circuitous path. So my current flow in my circuit is flowing throughout the entire loop of the circuit. I typically just draw it as an arrow across one element because eventually the concept of the current flowing through the entire circuit is just so clear to everybody that there's no need to draw something like a loop, but you will see this sometimes. But it's just assumed that you know eventually that if I draw this, then that same current flows here and here and here, okay, all through the circuit, because those charges are going to flow through the wires in the same direction all throughout the circuit. There's no way for them to flow this way and this way at the same time through the same wire. That just doesn't make any sense. Okay, so I just wanted to do a little bit of an overview of Ohm's law, and now in the next slide and the final slide of this section, I'm going to do one last example, and then we will be done with this this introductory sort of module here.